Hello, welcome all to my YouTube channel. This is my very first video on the lecture. So, I have chosen a topic from the operating system. This is a very famous topic from the operating system, spooling and buffering. So, let me start from very first slide. This is the introductory part of the spooling. So, what is spooling? Spooling is just an acronym for simultaneous peripheral operations online. So what does it mean? So let me start with the full form. So simultaneous means the processes which are going to be simultaneous means one by one, not one by one, but many processes are going to proceed at a single time. So simultaneous peripheral operations online. Peripheral operations are here input or output operations, and online means CPU is processing all. Means in the what can I say? Simultaneous means all the processes are going to be simultaneously proceed when the CPU is in on condition. So more than one input output operation can be performed simultaneously at a time when the CPU is executing some processes. Then more than one input and output operations can also be done at the same time. So there is a diagrammatic representation which I had made for you all. In this diagram, we can see that in the case of spooling, the input devices transfer all the data to the disk for at a single time. Many input-output devices gives large amount of information to the disk, and the disk is a digital device, and main memory is also a digital device. So the data transference between them will be very fast, and so it will save the time. And main memory fetch the data from the disk, and then CPU fetched all the information and the instructions from the main memory and proceed it and give the result or output to the main memory, and main memory give it to the disk. And then the same way as the many input devices have given the information to the disk provide all the output to the output devices. Okay, so moving to the next slide. What is a technique? A high-speed device like a disk is interposed between a running program and a low-speed device involved with the program input and output. It means a high-speed device like a disk means input devices are slow devices and output devices are also slow devices. So high-speed device like a disk is interposed between a running program and a low-speed device involved with the program input and output. So generally basic idea of spooling is just to reduce the time that it is taken by the CPU and input devices and output devices. So it just reduces the time. Communication. So the second point says the communication between a low speed device and high speed device is isolated. High speed device transfers the data to the spool. Low speed device gets the data from the spool. So what are the examples? The biggest example of spooling is printing. In printing, we see the documents which are to be printed are stored in the spool and then added to the queue for printing. During this time, many processes can perform their operations and use the CPU without waiting while the printer executes the printing process on the document one by one. So I think you have you understood at some extent. What are the advantages of spooling? So what I said earlier, performance of the system is increased, CPU and input device work more efficiently, leads naturally to multi-programming, and used for processing data at remote sites. So moving to the next slide. What is that? Now the topic comes buffering. So the definition of buffering is the main memory has an area called buffer that is used to store or hold data temporarily. This is being transmitted either between two devices or between device or an application. Buffering is an act of storing data temporarily in the buffer. It helps in matching the speed of the data stream between the sender and the receiver. The use of the buffer allows uniform disk access. The system places no data alignment restrictions on user processing during input-output. The use of the buffer can reduce the amount of disk traffic, therefore increasing overall system throughput and decreasing response time. Okay, buffering is done to deal effectively with the stream mismatch between the producer and consumer of the data stream. A buffer is produced in memory to heap up the bytes received from modem. After receiving the data in the buffer, the data gets transferred to disk from buffer in a single operation. This process of data transfer is not instantaneous, therefore the modem needs another buffer in order to store additional incoming data. What are the types of buffer? First one is single buffer. A buffer is provided by the operating system to the system portion of the main memory. It has a block-oriented device. On block-oriented devices, system buffer takes the input. After taking the input, the block gets transferred to the user space by the process and then process request for another block. OS can swap the processes. Stream-oriented device. Line at the time operation is used for this called terminals. Byte of operation is used in forms most terminals. Each keystroke is significant. Now second one is double buffer. On a block oriented, there are two type buffer in the system. One buffer is used by the driver or controller to store data while waiting for it to be taken by high level of hierarchy. Other buffer is used to store data from the lower level module. Double buffering is also known as buffer swapping. So this is what double buffer in the block oriented. Stream oriented, line byte. At a time I/O, the user process needs not to be suspended for input and output unless process runs ahead of the double buffer. Byte. At a time of operations, double buffer offers no advantage over a single buffer of twice the length. Now third one is the circular buffer. When more than two buffers are used, the collection of buffers is itself referred to as a circular buffer. In this state, data do not directly pass from the producer to the consumer because the data would change due to overwriting a buffer before they had been consumed. So now the comparison or the basic difference between the spooling and buffering. It overlaps the input or output one job with execution of another job. In the buffering, it overlaps the input output of one job with execution of the same job. Full form of a spooling: simultaneous peripheral operation online. In buffering, itself a terminology for it does not have a full form. And on the basis of efficiency, spooling is more efficient than buffering. Buffering is not efficient as spooling. On the basis of size, spooling considers disk as a huge spool or buffer. From the case of buffering, buffer is a limited area in main memory. So summary: spool means simultaneous peripheral operation online. Spooling overlaps the input-output of one job with the computation of another job. A high-speed device like a disk is interposed between a running program and a low-speed device. Buffer is an area of main memory which is used to store data temporarily during input and output data transfer. Spooling and buffering increases the system performance. Thank you so much. This is my very first video on the YouTube. I didn't have practiced much, so I don't have given my 100% to this, but I'm sure I will give my best next time. So if you like the video or do not like the video, please you can give me constructive feedback. You can criticize me constructively, but and thank you so much. This is my only very first video, so please like and subscribe if you want some few lectures. Thank you so much, and subscribe to my channel if you like to watch my videos again. Okay, thank you so much.